The third big idea that we're going to learn about with navigation is that of the nautical mile, which is the unit we use to measure distance normally, and the knot, which is a unit of speed, which is normally used to measure distance. So if we think about important vocabulary, 1 nautical mile is the same as 1 minute on a great circle, which is 1,852 meters. We need to determine the distance by the latitude scale, so look up on the up and down scale. Now remember, 1 degree is the same as 60 minutes, which is the same as 3,600 seconds. Another way to express that is 1 minute is the same as 1/60th of a degree. We also have learned that 1 degree along a great circle is 111.2 kilometers. 1 knot is 1 nautical mile per hour, and speed equals distance over time. So we know that Earth is a globe or a sphere, has 360 degrees in it, but if I look at one of those degrees and break that into 60 small pieces, that one of those would be a minute, and 1 minute is a 60th of a degree. And so the distance on the surface of the Earth is 1 nautical mile. If it's 1/60th of a degree or 1 minute, we say that's a nautical mile if it's on a great circle. So we're going to look at 3 conversions today. First of all, let's convert 12 degrees and 45 minutes into minutes. So all we need to remember is that there are 60 minutes for every degree, so it's just 12 degrees multiplied by 60 minutes for this one here, so converting 12 degrees and 45 minutes, and we just need to multiply those together as I already said and add on the extra, so that should be 720 minutes. Let's have a look at the next one. If we want to add degrees and minutes, for example, I want to add 13 degrees and 37 minutes to 38 degrees and 52 minutes. Let's first of all add those degrees first. So we're going to add the 13 and the 38 together to get 51 minutes. Then we're going to get the 37 and the 52, add them together, and they will add to 1 degree and 29 minutes. Remember, once we hit 60, it's a new degree. So once we've done that, we're going to add the 51 degrees and the 1 degree and 29 minutes, and that should be a total of 52 degrees and 29 minutes. If I want to have a look at the final one, subtracting degrees and minutes. Now I can say for example, 43 degrees, 17 minutes minus 38 degrees and 52 minutes. We're going to minus minutes first. So we're going to say, what is 17 take 52? Now, we all know that's a bit of a problem. So what we want to do is borrow a degree from 43. So what we're really going to do is we're going to say 42 degrees plus 1 degree is 42 degrees plus 60 minutes, and then we can add the 17 minutes on. So what we really have is that 60 plus the 17 to make 77 minutes. Now that's going to be quite easy. 77 take 52, here's our 52, will just be 25 minutes. So I've just got to remember to take off that 1 degree that I borrowed up here. So it's 43 degrees minus 1 degree minus 38 degrees, and that should give me a total of 4 degrees. Just remember, be quite careful with reading the latitude scale. Look at the minutes here, so I can see that I've got 1, 2, 3, 4, 5 spacings. So 5 spacings, and there are 5 numbers from 25 minutes to 30, so that I know that this is going to be 26 minutes, 27 minutes, 28 minutes, 29 minutes, and so on. Now let's have a look at a problem on finding the shortest distance in nautical miles between 2 points. So if I want to find the distance from 69 degrees north, 50 degrees west, to 14 degrees north, 50 degrees west, I notice that this one and this one are the same. So we're traveling along a great circle, and the great circle is the 50-degree west circle. So we're traveling a total of 14 nautical miles. So no, we're not. We're traveling 69 degrees north to 49 north. We're actually traveling 55 degrees north on the great circle. Now we just need to convert this to minutes. So 55 degrees times 60 minutes per degree. So we're traveling 3,300 minutes, and that's just the same as saying 3,300 nautical miles, because we're traveling along a great circle. Now, if we want to do this in kilometers, there's one final step, and we can see that we've got the 3,300 kilometers here. We just need to recall that for every nautical mile there's 1.852 kilometers. So we're just going to multiply that 3,300 by 1.852 to get 6,111.6 kilometers. We'll also be faced with problems asking you to determine the speed of arrival, or the time of arrival. So we will need to know things like speed, distance, or time for these calculations. We'll need to know 2 of the 3 to work out the rest. So we'll have a look at the example. A vessel travels from 27 degrees, 10 minutes south, 160 degrees east, to 27 degrees, 20 minutes south, 160 degrees east. So we're on a great circle. So that's great. We're traveling at a speed of 15 knots. If it leaves at 10 AM, what is the estimated time of arrival? So as I said, we need to find out 2 of the 3 things from the speed, distance, and time formula. So here's a nice clue. Speed is told for us here. So here's our speed. We also can notice a distance in nautical miles. We're traveling along a great circle. We're only traveling a matter of 10 minutes along the surface of the Earth. So that's 10 nautical miles. So the question is going to ask you, what is the time? So we need to rearrange the strategy. So there's a logical way to rearrange this. So if speed equals distance over time, then this one and this one can swap places in this sort of formula, and therefore time should just equal distance over speed. So I know the time. No, I don't know the time. I know it's 10 nautical miles over 15 knots, which is nautical miles per hour. So that's left with 10 divided by 15, which is 0.6667, or 2/3 of an hour. And if I were to calculate that into minutes, I would need to use this number here and multiply it by 60 minutes per hour. So 0.6667 multiplied by 60 will give me 40 minutes. So the estimated time of arrival, we can see this, it leaves at 10 AM, and then we've worked out how long our journey will take. So 10 AM plus 40 minutes, we should arrive at 10:40 AM. So when we want to find speed, distance, and time, I often recommend you to think of it as a triangle. If you want to rearrange the formula, speed equals distance over time. Now I'm going to put that there and a divided by there. So if I want to find distance, all I would need to do is I would put my finger over distance, and then I could read what's left. So in this case, distance here, and then I would just read across equals speed times time. If I were to do it for time, I'd put my finger over time, and then I would read up and down, and so reading distance on top and speed on the bottom. So time equals distance over speed. Now it's your turn. I'd like you to open up to page 262 and have a go at exercise 5C, please.